Hey there, students! Ever wondered how the world around you keeps moving the way it does? Today, let's dive into the unshakable laws of motion, brought to us by the legendary Sir Isaac Newton. These laws, despite being centuries old, are still the backbone of modern physics. So, let's break them down and see how they shape our world today. First up, Newton's first law, the law of inertia. Simply put, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force. Imagine a soccer ball just lying on the grass. It won't move unless you kick it, right? That's inertia in action. Now, think about slamming on the brakes in a car. You lurch forward because inertia wants to keep you moving. Hence, seatbelts, your best friend in a sudden stop. And in space, a spacecraft just keeps on cruising at a constant speed since there's hardly any force to slow it down. The more massive an object, the more inertia it has. That's why a bowling ball is tougher to push than a tennis ball. Next, let's talk about Newton's second law. Force equals mass times acceleration, or F equals ma. This law shows how force, mass, and acceleration are interlinked. Picture pushing a grocery cart. The harder you push, the faster it goes. But load that cart with groceries and it's harder to get it moving. When you throw a ball, the more force you use, the faster it accelerates. Similarly, a sports car with a powerful engine accelerates quicker than a small car with a less powerful engine. Bottom line, to make something accelerate, you need to apply force. And the bigger the mass, the more force you need. Finally, we have Newton's third law, action and reaction. For every action, there's an equal and opposite reaction. When you walk, you push against the ground and the ground pushes back, propelling you forward. In a rocket launch, the rocket expels fuel downwards and the expelled gas pushes the rocket upwards. Swimming works the same way. Push water backward and it pushes you forward. Even sitting in a chair involves this law. You push down on the chair and it pushes up on you, keeping you in place. Remember, these forces act on different objects, so they don't cancel each other out. Now, why do Newton's laws still matter? While modern physics has given us deeper insights, Newton's laws remain incredibly accurate in most everyday situations. They're crucial for engineering, mechanics, and more. From building bridges to launching satellites, these laws continue to guide us. Understanding them isn't just academic, it's about grasping the principles that govern our daily lives. So, next time you see a soccer ball, drive a car, or even sit in a chair, remember Newton's laws at work. They're everywhere, shaping our world. Thanks for watching and keep exploring.